Alright guys, we're going to start this out by doing a little bit of a review over some of the topics we've already covered this year. So we're going to start out with solving equations. Now it's going to be a big solving every different type of equation. So the first thing we're going to have to identify is what type of equation are we dealing with. And the way that you do this is you find out where's x. Okay, so x can be in a bunch of different spots. So take your linear equation, for example. So x is just hanging out by itself. All right, there's no symbol around it. There's no exponent. It's just x. You can have something multiplied by it, but that's about it. Okay, so just x kind of by itself. This is your basic linear equation. All right, you can add an exponent in there. Okay, so we can have, let's use the same equation again, but make it 2x squared plus 3 equals 5. All right, once it becomes an x squared, that's a quadratic equation. All right, and the rules for solving this are a little bit different than just solving your basic linear equation is. All right, you have to use some different types of methods. That's why you have to identify what you're dealing with. Okay, in the same vein as quadratic, you can have other exponents like x cubed or x to the fourth. Okay, and those would follow a similar procedure to quadratics as well. All right, another situation you might run into is x is in a radical. All right, so this is your radical equation. All right, and the radical could have like a cube root or fourth root. All right, and again, all those are going to follow a similar procedure of solving. Okay, so if x is inside one of those symbols, okay, you got to know how to deal with that. Then we have when x is in the denominator. All right, this is called a rational. This is what we just got done doing right before spring break. So anytime you find x in the denominator, it's a rational equation. So that's going to have its certain procedures that you want to follow for that type of equation. All right, and then the last one that we've already covered this year is inside an absolute value bar. All right, and hence the name. This is absolute value. All right, and again, each one of these has its own procedure that you want to follow to solve. Okay, a lot of the procedures are very similar. Sometimes while you're solving one type of equation, you end up and you have another type. So like we're solving an absolute value, but then all of a sudden it becomes a quadratic, and now we're solving a quadratic equation. Okay, so you gotta kind of roll with the punches on these. Okay, your whole goal for solving equations is to get x by itself. Okay, you got to do legal, mathematical things to make that happen. All right, opposite operations. That's what it's all about. So we're going to just go through a few examples here. It's probably going to cover a couple different videos. All right, maybe even 3 if I add in literal equations at the end. All right, so this is what you're going to be dealing with here. These are a little bit more complex. Okay, we're going to give you ones that are a little bit higher level here, especially since some of this stuff is kind of Algebra 1-ish, especially the linear equations. All right, some of the other ones that we learned more recently, all right, they'll be very similar to what you've already seen on your tests and quizzes. All right, so let's take a look at this first equation here. We've got a whole bunch of x's here, but if you look at all of them, what type of equation is this? Okay, well, there's no square root. It's not in the denominator. There's no exponent. All that's happening is something's multiplied by x. So this is going to fall under the linear type. All right, and if it's linear, this is going to be the easiest type to solve. You follow your operations, then you get all the x's on one side, all the numbers on the other, and go from there. All right, so we know what to do here. We've got a number outside the parentheses, so we're going to have to distribute that. So this is going to be 6x minus 14. Same thing here. So that's going to be 12x plus 8. Same thing here. That's going to be 30x plus 54 plus 3. All right, I've got a bunch of like terms that I can combine. So here I have a 6x and a 12x, so that's 18x. And then I have a negative 14 and a positive 8, so that's negative 6. Here I have 30x, and I have 54 and 3, which is 57. Alright, now I need to get all my x's to one side, all my numbers to the other. It doesn't matter which way you go. Okay, so I'm going to move my 30x's over to the left by subtracting that. And I'll move my 6 over to the right. So I get 18 minus 30, that's negative 12x. And 57 plus 6 is 63. Alright, and then I finish this up by dividing by negative 12. And you get x equals negative. Alright, when you get a fraction like this, you want to see if you can simplify it. Okay, this one you can simplify it. Let's use our calculator to kind of help us out here. Okay, I don't want to lean on the calculator too much, but for things like simplifying a radical or simplifying a fraction like this, that's where the calculator is going to be very useful to us. So just type in 63 over 12. I know it was negative, but that doesn't really matter for this. All right, 21 over 4. 21 over 4. So it looks like both of these were divisible by 3. Alright, and that's going to be your final answer. When you're solving these out, you want to try to be as organized as possible. See how we went down row by row until we got to our answer, then you boxed your answer at the end. Okay, try to be as organized as possible, especially for me, when I'm reading this stuff, I want to be able to follow your work. Okay, and if you are just writing stuff all over the place on these, then it's kind of hard to follow, and I don't know exactly what's going on. Alright, let's take a look at this one over here. So this one's kind of tricky in the way that it's written, but again, what type is this going to be? Okay, so if you look here, the radical ends right here. So the x is not inside the radical, it's outside the radical. Okay, which means that it's just being multiplied by a number. Square root of 2 is a number just like any other number. Okay, so x is being multiplied by a number. It's power of 1. It's not in a denominator. So this is a linear equation as well. Alright, but it doesn't look like it. That's why I wanted to show you this example. It looks like it should be a square root, a radical equation. But it actually is linear because of where the x is. Alright, and that's the important thing to look at. So we can solve it just like we did this one. I'm going to get x by itself. So let's move this number to the other side. We can just add square root of 3. So you get square root of 2x equals... Now, we can't really add these together. If you remember from our radicals unit, you cannot add or subtract if they don't have the same number inside the radical. So I'm just going to leave this like this for now. We can get a decimal approximation of our answer at the end if we want. Okay, and then we can divide by the square root of 2. Since it's being multiplied, dividing would be the opposite operation. So we can divide this whole thing by square root of 2. So that'll leave me with x equals... Alright, now there's a couple different routes to go here. Usually for pure math people, we want the we want this to be in radical form, because that's the most exact way to write the answer. But we also, if you remember, are not allowed to leave a radical in the denominator. Okay, so here's what we want to do here. To cancel out that radical in the denominator, I'm going to multiply by another square root of 2. The reason I do this is because the square root of 2 times the square root of 2 is square root of 2 squared, which is 2. It's going to cancel the radical out for us. Now, when we're dealing with fractions like this, you always multiply the top and bottom by the same thing, because that's multiplying by a 1, which doesn't change the inherent value of that fraction that you started with. Okay, so on the top here, we're going to multiply the square root of 2 in. I'm going to distribute it. And multiplying doesn't have the same rules as adding, so I'm allowed to actually multiply these. So square root of 5 times square root of 2 is square root of 10. Square root of 3 times square root of 2 is square root of 6. And then square root of 2 times square root of 2 is 2. Because the square root cancels out when we do that. That would be the most exact form of the answer. Depending on what type of problem you're dealing with, you may want to get a decimal approximation. So you would take that and plug it into your calculator. Okay, so we can do square root control x squared of 10. Let's try that again. plus, make sure you arrow out of the square root, so otherwise it'll type everything underneath it. So we'll do another one, square root of 6. Alright, and I want this whole thing to be divided by 2, so I'm going to put it in parentheses. Then if you press Control divided by, you can get a nice looking fraction like this, divided by 2. And hit Enter. 2.81. Alright, 2.81. Remember, box our answer. Okay, we box this one underneath. Alright, and if you want to verify that this is actually the same thing as what we got before, you can type in the other one. So square root of 5 plus the square root of 3. And then parentheses, and we'll divide that by the square root of 2. And this is just a good way to verify that your simplified form is the same thing as the actual answer you got when you got x by itself. Alright, you can see the same decimals there. Alright, let's move on to this. Alright, so now we're looking at x. So we're saying, what type of equation am I dealing with? Okay, and I see I have an x with an exponent. It's got an x squared. So squared is specifically called a quadratic equation. Now, it could be a cube or a fourth or a fifth, but that would be called a polynomial equation. Quadratics are a specific type that you see a lot in other types of things. And y'all have experienced that already. And when we do get to our last new unit, you'll see more quadratic equations again and again. Okay? So, first thing I would do, we have a bunch of different methods. We can factor this. We can complete the square. We can do quadratic formula. Or we can use our calculator. Now again, I don't like to lean on the calculator too much, so let's try one of these other ones first. Factoring is the easiest. Alright, the problem with factoring is not everything factors. Alright, so we know that this would be x times x, because x times x would be x squared. That gives us that. So now I need numbers that will multiply to be positive 3. And add to be negative 5. So my only options are negative 3 and negative 1. Those multiply to get positive 3, or positive 3 and positive 1. Okay, no other numbers multiply to get positive 3. These are my only two choices. Okay, so we have to say, do either one of these add up to negative 5? So that adds up to negative 4. This one adds up to positive 4. So the answer is no. So factoring is not an option on this one. Okay, so complete the square. All right, you can always complete the square. You can always quadratic formula. You can always calculator. Calculator is not the best because it's only going to give you a decimal approximation instead of a more exact answer. So let's go over completing the square. All right, this is the one where you want to add in a plus blank after the x, and then you're actually going to move that 3 over. So we're going to subtract 3. So set this equal to negative 3, and then we're going to add a plus blank over here. Okay, then you take the middle term and divide that by 2. Okay, you can't reduce that, so we'll leave it like that, and then you square it. This is how you get the blank. So that's 25 over 4. Alright, then this thing on the left will factor into a perfect square. X plus or minus something, and it's always what this number was from the previous step, so it's going to be x minus 5 halves squared equals, and then you add these two things together. Okay, let's use our calculator here to help us out. So negative 3 plus 25 over 4. That's 13 over 4. Alright, and then to finish this out, remember we have to get x by itself. That's when we know we're done. So to get rid of a squared, the opposite of that is a square root. Okay, and anytime you square root something, you want to put a plus or minus. We don't do it on this side because the square root is just going to cancel out with the squared. So that's x minus 5 halves equals plus or minus the square root of 13 over 4.